Hello, welcome to today's lesson. So for today's lesson, you will need a filled out unit circle. So please locate one of those. And you will not need to take any notes during this video. I'll make sure you get all the notes you need next time we get together in class. Just to let you know where we've been and where we're headed, in chapter 4, we've completed these sections. And where we're going next is we're starting section 4.5 today. We're going to do section 4.5, 4.6, and 4.7 in order. That'll take us pretty much until the end of January. All right, so let's begin. What we are going to be doing in today's lesson is we are going to graph y equals sine of x. So we call this our basic sine graph. The first thing you notice probably is that the graph paper looks quite different than our usual graph paper. The x-axis is going to be for the angles because that's what you put into the sine function. All right, and notice I have pi over 2 and pi and 3 pi over 2. Those are some angles that you recognize. The y-axis will be the ratios because we put angles in, we get ratios out. So notice that we only go up to 2 and down to -2. As it turns out, we won't even need that much on the y-axis. We're not even going to go all the way up to 2 or down to -2, as you'll see as we get the graph going. Before we start plotting any points, let's take another look at the x-axis, and let's talk about each of these tick marks. Okay, you can see that this is labeled as pi over 2 and this is labeled as pi. Question for you, what is one tick mark here? What is this distance from here to here? It's pi over 6. It's pi over 6. One way to tell is it takes 6 of them to get to here. So 1, 2, 3, 4, 5, 6 gives you a full pi. So that's pi over 6. This would be 2 pi over 6. Instead of 2 pi over 6, we would call that pi over 3. This is 3 pi over 6, which we would reduce to pi over 2. The next would be 4 pi over 6, which reduces, and then 5 pi over 6, and so on. So that's what we're looking at on the x-axis. All right, let's go ahead and start to plot some points. You're going to need your unit circle. I'm going to make a table. Remember, you don't have to write any of these down because it's really just I'm just going to take a long time kind of to create a table the very first time we see this graph. Once we've seen this graph, we'll have shortcuts for how to graph it in the future. All right, but I'm going to make a table here. I'm going to put in angles for x. I've selected some angles we'll put in. And we're going to find the ratio. So first I'm going to put in 0. So we want to find the sine of 0. So look on your unit circle. The angle 0 out there to the right, the ordered pair is 1, 0. Which is the value of sine? Well, it's the y coordinate. So if you look on your unit circle at the angle 0, you have 1, 0. This is the value of sine. All right, so when the angle is 0, the ratio is 0. That's my first point to plot on my sine graph. It's an x-intercept. It's also the y-intercept. Let's go next to pi over 6. All right, we want to find the sine of pi over 6. So look on your unit circle. The sine of pi over 6 is going to be 1/2 because it's the y-coordinate on the unit circle. So the point that I'm going to plot on this graph is pi over 6 1/2. When the angle is pi over 6, the ratio is 1/2. For pi over 4, look on your unit circle at pi over 4. The y-coordinate is radical 2 over 2. Now, radical 2 over 2, I don't have that indicated on the y-axis. So if I sneak a calculator, I can get a decimal approximation for that. And that's about 0.71. So what I'm going to do is estimate. Oh, pi over 4 is not listed. But if you look on your unit circle, guys, you know that pi over 4 is right halfway in between pi over 6 and pi over 3. So pi over 4 would be here. And we get 0.71. I'm going to estimate right about there. All right, next, sine of pi over 3. Look at your unit circle. Look at the ordered pair for pi over 3. The y-coordinate is the value of sine. It's radical 3 over 2. Again, I'm not sure exactly what radical 3 over 2 is and where to plot that, so I'm going to sneak a calculator, and that's about 0.87. So I'm going to plot the point pi over 3, 0.87. I'm going to estimate right about there. The next angle is pi over 2. So look at your unit circle. Up there at the angle pi over 2, you have the point 0.01. The value of sine is 1. So the point I'm going to plot on my graph is pi over 2, 1. All right, and you can see we start to have a graph coming in here, kind of like that. All right, let's continue our way around the unit circle to make our sine graph. Up next, I've selected 2 pi over 3 for us. That should make sense. That's the next angle on your unit circle. And the value of sine of 2 pi over 3, go ahead and grab that y-coordinate. It's radical 3 over 2, which is 0.87. Going to estimate. Now, I know next on your unit circle is 3 pi over 4, But since those aren't labeled on the x-axis, let's go ahead and skip to 5 pi over 6. So the sine of 5 pi over 6, look at your unit circle. At 5 pi over 6, the y-coordinate is 1/2. So I can plot the point 5 pi over 6, 1/2 on my sine graph. And then next, I have pi. All right, so the sine of pi, look out there to the left on the unit circle. The y value is 0 at that point. So on the unit circle, if you look at pi, the y-coordinate is sine, and that's 0. So when the angle is pi, the value of sine is 0. When the angle is pi, the value of sine is 0. So I'm going to plot the point pi 0 on my graph. And here's what we have to start our sine graph. That's not the whole thing. That's just the beginning of it. Okay, we have that nice, I call it a hill. Looks like a hill there. All right, let's keep going. The sine graph does not end at pi. So let's continue our table. I'm going to make a smaller table now because I don't think I need to put this step of work for you at this point. The next tick mark is 7 pi over 6. The one after that would be 8 pi over 6. That's 4 pi over 3. Let's plug those in and see what happens. So look at your unit circle at 7 pi over 6. The y-coordinate is the value of sine. So we're going to plot 7 pi over 6, negative 1/2. Look at your unit circle at 4 pi over 3. I'm jumping over 5 pi over 4. So look at 4 pi over 3. It's negative radical 3 over 2, which is about negative 0.87. Going to estimate. And then at 3 pi over 2, everyone look at your unit circle down there. The point is 0, negative 1. So the value of sine is negative 1. And I think you can start to see what's happening here. So what I'd like to do, if it's okay with you, is we'll skip 5 pi over 3 and 11 pi over 6. Let's jump over to 2 pi. Look at your unit circle. At 2 pi, the value of sine is 0. So if you're okay with it, I think you can see that after this hill, we're going to have a valley like this. Okay, looks like this. And if you don't quite believe it, you're welcome to plug in and find the values of sine for 5 pi over 3 and 11 pi over 6. But what you have for this first part of the graph is a hill followed by a valley. The graph does not end at 2 pi. The graph continues. So let's go ahead and plug in 5 pi over 2. Now, to find the sine of 5 pi over 2, we want to remember that 5 pi over 2 is all the way around, right? Because that would be 4 pi over 2 and another pi over 2. So that's 5 pi over 2. 5 pi over 2 is coterminal with 90 degrees or pi over 2. Look at the ordered pair up there on your unit circle. The sine value of sine is 1. Okay, now how about 3 pi? If you think about sketching 3 pi, it's all the way around 2 pi. 3 pi is going to bring you over here. It's coterminal with pi. So look at your unit circle. The ordered pair for pi is negative 1, 0. So the value of sine is 0. So what we have now is another hill. This is a repeating graph. So what's going to happen after this is we're going to have a valley. If we were to plug in the next one out here, let's see, if we were to plug in, I'm going to skip over to this one. This would be 7 pi over 2. We would get negative 1. And this over here, I'm going to skip over here to 4 pi. If we were to plug in 4 pi, we get back to 0. The graph does not end at 4 pi. What happens after this is it repeats. There'd be another hill and another valley forever and ever and ever. This graph never ends. Notice, please, when I go to sketch the graph, I don't connect with straight segments. So I'm not drawing linear segments. Do you notice that I'm drawing some nice curves here? Okay, another way to discuss this is to bring up concavity. The hill is concave down like a frown. The valley is concave up like a smile. Okay, so concave down and then concave up. Now that's what happens for this graph to the right of the y-axis. Is there a part of the graph to the left of the y-axis? Can we plug in negative values for our angles? Absolutely, you can have negative angles. So if you want to figure out what's going on to the left of the graph, left of the y-axis here, we want to plug in negative pi over 2, negative pi, negative 3 pi over 2. I'm just skipping over to just those angles. Instead of plugging in, I could do negative pi over 6, negative pi over 3, but that's a lot of work. I think you're going to start to see what's going on here. All right, so let's look at negative pi over 2. Find negative pi over 2 on your unit circle. That's down there, coterminal with 3 pi over 2. The value of sine is negative 1. Okay, negative pi. Find negative pi on your unit circle. That's coterminal with pi. The value of sine out there to the left is 0. Okay, now look at 3 pi, negative 3 pi over 2. On your unit circle, negative 3 pi over 2 would be up here. It's coterminal with pi over 2. Up there, the ordered pair is 0, 1. So the value of sine is 1. And if we go all the way to negative 2 pi, we're coterminal with 0 or 2 pi. And the ordered pair here would be 1, 0, which means we're back to 0 for the sine graph. All right, and once again, I'm not going to connect with straight segments. I'm going to make a nice concave down hill and a concave up valley. And the graph does not end at negative 2 pi. This graph continues forever to the left and right with this repeating pattern. So an important characteristic of this graph is its domain, and its domain is all real numbers. We are only looking at a small part of this graph. This graph continues forever to the left and the right. That's the domain. How about the range? The range is not all real numbers. The range is from negative 1 to 1 with brackets, because the lowest the graph ever goes is negative 1, and the highest the graph ever goes is 1. So I'm using brackets because we actually do achieve negative 1 there. We do go as low as negative 1. We want to include that in the range. And we do go as high as 1, but we don't go above it. Another important characteristic of this graph is the y-intercept. I put a star next to that. You'll see why after break that's an important characteristic. Another thing to discuss here is whether this graph is even, odd, or neither. To be even, you'd have to be symmetric with respect to the y-axis. To be odd, you'd have to be symmetric with respect to the origin. We think of that as rotational, 180-degree rotational symmetry. So is this function even, odd, or neither? Your basic sine graph is odd. It's kind of hard to tell because right now we can see more of the graph to the right than the left. But if I kind of cover this up, it might be easier to see. Okay, so if I cover that up, if I spin this 180, it's going to map onto itself. So see how from the origin here, it goes up to the right for a hill and down to the left for a valley? If I spin that graph 180, it does the same thing. It's kind of hard to see because we have some extra graph to one side. So let me cover up that extra piece there. All right, and if you look, sure enough, from the origin, it goes up to the right for a hill and down to the left for a valley, just like if we look back at the original. So this is an odd function. Another important characteristic of this graph is the fact that it repeats. So when you take a look at it, how far do you have to go before it repeats? Well, let's look at this piece here. Did I go far enough? If I go from 0 to pi, does the graph repeat after that? No. If the graph repeated after that, it would be a hill, then a hill, then a hill, then a hill. This graph takes a hill and a valley before it repeats. And that distance right there is 2 pi. So that's how far you have to go before the graph repeats. And if you look, if you go that distance of 2 pi, if you then were to continue, see how my fingers are in the same height as I go and trace along the graph maps onto itself. So if you could take this graph and move it 2 pi to the right or 2 pi to the left, it's going to be the same exact picture. It maps onto itself. That's a geometry word, MAP, maps onto itself. And it doesn't have to be this piece between 0 and 2 pi. It can be any interval that's a length of 2 pi. So for example, if we were to look at this piece, let's look from here to here. Okay, so that right there is a length of 2 pi. That's a 2 pi interval. Does the graph repeat after that? Sure, because if I were to trace this part of the graph and then continue tracing, the graph is doing the same exact thing over again. Every 2 pi units, the graph repeats. Another important thing to note about this graph are the locations of the x-intercepts, the maximums, and the minimums. Those are called critical points or critical values. The intercepts, the maxes, and mins, and they occur at a particular type of angle. So take a look at the intercepts, like these, and the maximums, like these, and the minimums, like these. What type of special angle do they occur at? They occur at quadrant angles. So I don't know if you noticed, but once we stopped in the beginning, we actually plugged in lots and lots of different x values. But right around here, I kind of just started plugging in quadrant angles Because if you know that this graph is going to be hills and valleys, if you can just figure out where you cross the x-axis and where the tops of the hills and the bottoms of the valleys are, the maximums and the minimums, then you're going to be able to make your graph. All right, so that's the first time you've seen our basic sine graph. And what we'll do next time we have class is we'll get some notes on this, and I'll show you guys a shortcut for how to graph so that you don't have to graph all of these points every single time. Thanks for watching, guys.